All right, friends, this is Module 12, Lesson 1. The date today is it's the 26th when I'm recording this. You're going to see this on the 28th of January. So we're going to start right off. What I'm going to do is I'm going to write everything up here, and then it'll probably be sped up when I'm writing it. You can pause it, write that down, and then continue on. So we're talking about light and all the characteristics about light and what light does. So put the date 1/28/25 up there. We're going to get started. To see an object, it must reflect light back into your eyes. Objects can absorb, reflect, and transmit light. If it's opaque, that means that it only absorbs light and reflects light, but no light passes through it. So, if we have a book here, and I have my flashlight, this is opaque. No light is getting through this. Pause it if you need it. Something is translucent if it allows light through, but it also scatters it. So, we have light. You can still see the light. It's allowing light through, but it's scattering that light. It's not a clear through light. So that is translucent. If something is transparent, that material allows light to be transmitted through without scattering, so you can see through that clearly. Transparent. You can see through this, and it doesn't scatter the light, so you can see clearly through that. Now, this isn't a perfect example because of its shape, it's bending those light waves, so it's not a perfect example. Probably a more perfect example would be the lens of my flashlight, where this is just a glass piece and it allows all the light through it because it is transparent. So reflection occurs when light hits an object and that light bounces off. There is reflection occurring on this, and the light is bouncing off. There is, screenshot if you need it. There is a law of reflection. The law of reflection states that the angle at which a light wave strikes a surface is the same angle at which it is reflected. So if I have a light wave coming down from the overhead light hitting at this angle, it's going to bounce off at the same angle downward. So we have an angle. If this is a surface, the angle is going to bounce off, and we have the neutral line. This angle is the same as this angle. So if we have a smooth surface like a pane of glass or a mirror, the image will be sharp because the reflected light will be parallel and only back directed in one direction. So we have different surfaces, different surface finishes. Glass is very smooth. A mirror finish, very smooth. But we have objects that light is bouncing off them, but the surface has so many irregularities that the light is bouncing off in so many directions, not exactly back to us to where we can see through that thing, or have the light come back to where that is perfectly seen. So like a brick wall, that light wave comes and hits that uneven brick and it goes all over the place. Refraction, or we could also call it like the bending of light. That occurs when there's a change of speed because we're going from one material to another. So if we're going from a gas, the air, through a plastic material, we have refraction. That light is bent, that light changes because it's going through different medium. The index of refraction is a property of the material, and this indicates how much the speed of light in that material is reduced compared to the speed of light in a vacuum, which, as we've talked about, is 300,000 kilometers a second. So this is the index of refraction. It says how much the speed of light in the material is reduced. So the bigger the index of refraction, the slower the light will be through that material. Pause it if you need it. On page 305, we're going to talk about prisms. And I'm just going to read to you about prisms because they say it as good as I could or better than what I could do on the notes. So we're going to read on 305 prisms. So you listen for the information. A sparkling glass prism hangs in a sunny window, refracting the sunlight and projecting a colorful pattern onto the walls of the room. How does the bending of light create these colors? It occurs because the amount of bending usually depends on the wavelength of the light. Wavelengths of visible light range from longer red waves to the shorter violet waves. White light, such as sunlight, is composed of the whole range of wavelengths. When white light passes through a prism, the triangular prism refracts the light twice. Once when it enters the prism, and again when it leaves the prism and re-enters the air. Because a longer wavelength of light has a smaller index of refraction, it is refracted less than the shorter wavelength. As a result, these different amounts of bending, the different colors are separated when they emerge from the prism. Red light is bent the least. So remember our colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. Those 7 colors, those are because the light is refracted. So rain droplets refract the light where the white light from the sun separate into individual colors that we see when we see a rainbow. The human eye can distinguish 7 colors clearly in the rainbow. And as Mother Goose says,
red, orange, yellow, green, blue, indigo, and violet too. Red, orange, yellow, green, blue, indigo, and violet too.
so a mirage, how a distant object is distorted because the refraction of light is changed through the many air layers, the different densities of air. So as air is warmer, it is less dense. As it becomes cooler, it is more dense. So the light going through those different air layer densities refracts the light. So as it's warmer, air density is reduced. As it is cooler, air density increases, so the light waves will travel slower in cooler air, in more dense air. All right, that is lesson 1 from module 12. Make sure those notes are in your notebook, and we will see you tomorrow.
Rainbow, rainbow, high and bright. Rainbow, rainbow, made of light. From the clouds down to the ground, I see colors all around. Red, orange, yellow, green, blue, indigo, and violet too. Red, orange, yellow, green, blue, indigo, and violet too. A rainbow. the rainbow.